The Woojin Quality Graph is a tool used to monitor the quality of injection or plasticizing process. Let's take a closer look on the page itself. The page is divided into the following areas. Trace settings, where the user can activate and set up the recording. Trigger settings, used to select what triggers the start of the recording. Envelope graph area that displays the curve and allows fine-tuning of the envelope. Border adjustment zone, used to configure the X and Y axis tolerances. If we scroll to the bottom of the page, we will see the shot status area. Here a matrix of indicators gives an overview of good and bad parts produced based on the envelope requirements. Let's go back to the top now and see how to set up the page. In the trace settings area, we first have to activate the envelope curve monitoring. This is done by activating the checkbox. Next we need to set the time settings. Trace time determines how long the recording will last, and the delay time delays the start of the recording after the trigger signal. Good and bad part separation can be used to control the separation of parts with some external functions, like the conveyor belt in the robot. Let's leave it unchecked for now. Sampling time determines how often the PLC gets the graph data. Class 1 is the fastest, and offers the highest precision, but limits the length of the recording to approximately 22 seconds. Higher classes offer longer recording time but at the cost of precision. In our case 22 seconds is more than enough, so we will leave it at this. If we would like to see how the graph changed over the last several shots, we can change this value to show a set of previous curves. These will be shown on the graph but faded in comparison to the current graph. We will set this value to 5 previous curves, but you can set it to any number you want, or leave it at 0. Next we need to take a look at the trigger settings. Here we can select which reference signal will trigger the start of the recording. For this example we will select injection pressure. Changing the reference signal will automatically reset the graph data below. The previous set of curves can now be seen as a faded curve. Let's see what happens now when we inject. Since the graph data was reset when we changed the trigger signal, new data will be loaded during injection, showing the injection pressure graph. Once the trace time is over, positive and negative border values will automatically be calculated, based on the border adjustment values set below. If we click on any point of the graph, a cursor line will appear. It provides precise information about time, pressure and stroke, as well as positive and negative tolerance values of any point of the graph. Envelope borders can of course be adjusted. When we change the plus and minus tolerance values, we are changing envelope on the y-axis. If we change the time tolerance, we are changing envelope on the x-axis. A more precise border adjustment is possible by using the plus and minus buttons on the cursor line. By using the sensitivity slider, we can also adjust how precise the adjustment is. On the left and right side of the graph we can see 2 markers, T1 and T2. These are used to select which part of the envelope graph will be monitored. The button under the left side of the graph is used to automatically adjust the graph to best fit the area. On the right side we have the reset button, that resets the graph. Let's now go ahead and reset it, and then see the envelope curve in use. Once the automatic cycle is started, the first injection shot will be used as a reference. Based on this reference, the envelope limits will be calculated automatically. The user can of course manually adjust the limits after this to his own liking. Let's wait shortly for the second shot to see the behavior. If the next shots are inside the envelope borders, they will be flagged as good parts. This will be visually shown in the good-bad part area via green indicators. Once the next shot is being injected, the green indicator for the previous cycle is shown. In case there is a change in the process and the curve ends outside of the envelope, the indicator will be red, to indicate a bad part is produced. Now we can also show how selecting monitored part of the curve works. If we move the T1 cursor past the part of the graph that is outside of the envelope, we will ignore this part in the analysis of the part quality. This will result in the part being considered as good, which can be seen by the indicator color. With this we conclude this presentation. If you have any other questions regarding Woojin Quality Graph, please leave a comment below, or contact us directly through our customer service channels. Thank you, and have a nice day.